So in today's lecture we are going to discuss about your atomic scattering factor, or also this is also known as atomic form factor. So since we know that in the crystal X-ray diffraction your Bragg's condition, that is your 2d sine theta is equal to n lambda, this is the Bragg condition for the X-ray diffraction to takes place when the your values of your d and lambda and theta matches. So then there will be your X-ray diffraction by your lattice points. So this X-ray diffraction, the constructive interference of your waves is which are scattered from your lattice points, or you can say those are point electrons which are arranged in your crystal lattice. But in practical cases, the intensity of your incident beam which is diffracted, it depends not only upon the lattice points in the crystal, but it also depends upon the your grouping of atoms. That means how atoms are grouped in your unit cell and the scattering power of these atoms, which means you can say it also depends upon the bases of atoms. Basis, but I have told you that crystal structure is equal to lattice point plus basis. Basis means how atoms or group of atoms, means how many atoms are grouped in particular unit cell. So therefore in case of grouping of atom, your atomic scattering factor comes into picture. So this atomic scattering factor is defined as amplitude of radiation scattered from an atom to the amplitude of radiation scattered from a point electron. So now to derive your scattering amplitude for wavelength lambda of X-ray, so we will consider an atom having center A. So where this the charge that is charge is spherically symmetrically distributed along the center of your atom at the radius r. So therefore this is your small charge element, charge volume element dv, and this is happening, this is at the distance r from the center. So now then your rho r dv is your volume charge distribution. This is your volume charge distribution. So now let us consider a n point electron is situated at your center A. So this n naught unit vector is your direction of your incident wave, and n unit vector is your direction of your scattered or reflected wave. So now let us consider that scattering occurs along this direction capital N, then the phase difference between your this scattered by your wave scattered by your point electron and your scattered by this volume charge distribution is given by phi r. This is your phase difference. This will be 2 pi upon lambda into this r dot n. This is power difference. Phase difference is 2 pi upon lambda into power difference. So this is evaluated by using the Law's equation. So now you can say that you can also draw from by using Law's equation. This is your direction of your, that is scattered wave. This is your reflecting plane, and this is your incident wave having unit vector and not direction. So now this will be theta, this will be theta, this will be theta. So now using vector diagram, this will be your n vector. So now by using this vector diagram you can find out the value of your n. This is your perpendicular, this will be hypotenuse, this will be base. So since this is n, this will be n by 2. So therefore you can find out sine theta from here. From this angle sine theta will be p, I am taking magnitude, this will be y 2 upon magnitude of your unit vector n. So this will be n upon 2, because magnitude of unit vector is equal to 1. So therefore n will be 2 sine theta. So now I can write this equation as phi r, this will be 2 pi upon lambda r n cos phi. This is r, this is n, and angle between them is phi. So therefore this will be r n cos phi. So now put the value of n into this equation. This will be phi r will be 2 pi upon lambda. This will be r n your sine theta cos phi. सॉरी n की वैल्यू पुट कर दी हमने. n इज इक्वल टू 2 sin theta cos phi. So therefore this will become phi r will be 4 pi upon lambda, and this will be r sin theta into cos phi. So you can also write this in simple way. You can write this as mu r cos phi, where mu is equal to 4 pi on lambda into sine theta. So here this phi r is the phase difference between your between this intensity at this your point electron and intensity of scattering from this charge distribution between them, phase difference between them. Let the scattering amplitude from point electron which is at origin of atom in the direction n, which is scattering direction, which it will be a will be the amplitude into iota kx minus omega t, where k is wave vector 2 pi upon lambda, taking magnitude 2 pi upon lambda, and it is in direction n direction, scattering direction, and x is distance traveled along n, and omega is the angular velocity of your scattering wave. So now this is the scattering amplitude for a point electron which is at origin in the direction n. Now then the scattering amplitude from the charge distribution, volume charge distribution element, this is dv in direction n will be, this will be a iota kx minus omega t, plus there will be phase difference, that is iota phi r into your volume charge distribution rho r dv. This will be same, but there will be phase difference of this magnitude, and there will be your volume charge distribution of that electron in your volume element dv. So now this is the amplitude for scattering amplitude for point electron, and this is the scattering amplitude for your volume charge distribution in atom. Therefore by definition you can write your atomic scattering factor will be your amplitude of your atom, amplitude of waves scattered from atom. This will be kx minus omega t plus phi r into rho r dv, and scattering amplitude of wave from your point electron at origin, this will be a iota kx minus omega t. So now by solving this, e raised to power iota kx minus ओमेगा टी, इसको मैं ऐसे लिख सकता हूँ iota phi r rho r dv divided by a raised to power iota kx minus omega t. So this term will be cancelled. So now the remaining term will be your e raised to power iota phi r, where phi r is the phase difference between your scattering amplitude from your that is from your charge distribution to their that is scattering amplitude from a point electron at origin. This will be rho r d v, and if you put the value of phi r from equation 2, this will be e iota phi r is your mu r cos phi into rho r dv. This is equation number 3. Now since this is your atomic form factor or atomic scattering factor will be this is this is only from your charge distribution in an atom to your scattering amplitude from your point electron. So now this is only from your small charge distribution, volume charge distribution. So now if you want to find out this for whole atom, so you if you want to find a whole, so you will integrate this df to the whole volume charge distribution. This is only for your charge element, volume charge element. Now to find out full, you have to integrate over whole atom. So now this is your atomic scattering factor. This will be f, this is df, so this is integrated rho r to iota mu r cos phi into dv. Now it will be integrated on whole volume element. So now to find out this, so since I have told that your atom the charge distribution in atom is spherically symmetric, so this will be spherical symmetric charge distribution. So your this integration will be carried along your spherical coordinate, that is r, theta and phi. So since I've told you that this your spherical charge, since your atoms the distribution of electron is spherically symmetric charge distribution, so therefore that integration along df will be carried along in spherical coordinates r, theta and phi. So therefore this your volume element dv is a kind of your annular ring traversing as a annular ring of radius r sin phi, where this is width is your r theta r d phi, and your width is your thickness is dr. Since you can find out this r d phi can be, because this is r, this is d phi, so since your d phi, your angular displacement from here to here, d phi is known as d phi will be arc upon radius r. So this arc can be found out r theta r d phi. So this is your arc will be r d phi, this is came as this, and this will be r sin phi will be, because this is your this will be r, this will be r, this is your phi, this kind of a perpendicular, so this will be p, this will be h, this will be r sin phi. So this is a kind of a radius to this annular ring. So therefore your dv will be area into thickness area into thickness. Area will be circumference into radius, sorry, circumference into width into thickness. What is your circumference? Is circumference for circle is 2 pi r. What is r? R is r sine phi. What is your width? Width is your r d phi, and thickness is this dr. So this will be dv will be your 2 pi r square sine phi dr into d phi. So this is your volume element in your spherical polar coordinate, or also this is also known as Jacobian. This is volume element in spherical polar coordinates. So now if you want, you now put this value of dv into this equation, so we will get this will be f. There will be two integral. First for this your dr, if you put the value to this will be r0 to infinity, and this will be another for phi 0 to pi. This is the value in spherical polar coordinate. r की वैल्यू होती है 0 to infinity और phi की वैल्यू होती है 0 to pi, and theta की वैल्यू होती है 0 to 2 pi. So this will be rho r into iota mu r cos phi. This will be into 2 pi. I will put the value of this 2 pi r square sine phi into d phi into dr. So now I will solve for your this for first for this integral. So now I will solve for this integral. First of all phi वाले इंटीग्रल को सॉल्व करेंगे हम. Pi, this will be iota mu r cos phi into sin phi into d phi. इस वाले इंटीग्रल को सॉल्व करेंगे हम. So now to solve this integral, put, बिल्कुल सिंप्लीफाई करके put your x is equal to cos phi. Cos phi को हम x पुट करेंगे. So therefore dx will be minus sin phi into d phi. So this will be minus dx. So now अब लिमिट भी एक्सचेंज करेंगे. So now for phi 0 x will be cos 0 will be 1, and for phi is equal to pi, this will be x will be cos phi will be cos pi is equal to minus 1. So putting the limits and values of your cos phi to x, so therefore your this integral will be transformed into, put this equal to I, this is integral, this integral I will become 1 to minus 1 iota mu r x into, this is your minus sign will be there, to dx. So now if you want to absorb this negative sign, you can reverse your limits. Therefore there will be minus sign will be absorbed. So there will be minus 1 to 1, minus sign आएगा तो ये प्लस हो जाएगा. This will be iota mu r x into dx. So now this will be simple. So integration of exponential function will be iota mu r x divided by this iota mu r minus 1 to 1. So put this ब्रैकेट से बाहर ले आए, म्यू आर, put the value of the limits, म्यू आर दिस विल बी 1 माइनस -1 आएगा, दिस विल बी माइनस आयोटा म्यू आर. So now in the next step, multiplied and divided by 2. So this will become, by multiplying and divided by, this will become 2 mu r, and this will be 2 iota, this will be mu r minus mu r. This is nothing but your sine mu r in terms of exponential function. I hope you know that. Or this is from your de Moivre's theorem. So this will be 2 sine mu r upon 2 mu r. So therefore I have calculated the value of this integral. 0 to pi is phi is equal to 0 to pi. This will be iota mu r cos phi to sine phi d phi. This I have evaluated. This is 2 sine mu r upon mu r. So since this I have put this value, sin theta is equal to e raised to power iota theta minus e raised to power iota theta by 2 pi. So this is from de Moivre's theorem, sin theta in terms of exponential functions. So now put this value into your equation number that is your equation number this is 5. So therefore equation number 5 becomes r0 to infinity your 4 pi r square mu r into sine mu r divided by mu r. Equation number 6. So now as for small value theta, as theta approaches to 0, so since mu is your 4 pi upon lambda sin theta approaches to 0, this mu, because sin 0 will be 0, since therefore this mu, this will approaches to 0, and hence since mu approaches to 0, therefore sin mu r upon mu r, this also approaches to 1. So this is your sandwich theorem. For small values of theta, sin theta will approaches to theta, sin theta will be. So therefore since this is, we know that, because for small value of theta, sin theta will be approaches to theta, since sin 0 is equal to 0, so therefore since theta approaches to 0, sin theta will be equal to 0, and this is your sandwich theorem for small values of theta. Here इसको हम ऐसे लिख सकते हैं, लिमिट mu r approaches to 0, sin mu upon mu r approach is equal to 1. So putting this equation into equation number 6, your f will becomes 0 to infinity 4 pi r square rho r dr. So sorry, there will be dr. So since this is your nothing but this is your charge in spherical cell of thickness dr and radius r, so thus this integration will equal to your total charge in atoms, or number of electrons, that is Z in the atom, or you can say that this integral represents the atomic number of the atom, which is equal to Z. So therefore this represents the total charge in the atom or number of electrons in the atom, or you can say that this is your atomic number of your particular atom Z. So therefore F is equal to Z, your atomic scattering factor is equal to atomic number for theta is equal to 0, or for small value is equal to 0, and F will be less than is equal to Z for all values of theta. So since this atomic scattering factor is equal to your atomic number for theta is equal to 0, and also this atomic scattering factor is less than Z atomic number for all values of theta. So since we can say that the overall electron distribution in solid obtained from your X-ray diffraction, this is fairly close to that of appropriate free atoms. This is fairly close to that of appropriate free atoms in your crystal.